Thanks everyone for joining me tonight. I'm going to be talking about something interesting tonight about space. I know everybody or everyone knows about speed of light. There's nothing that can travel faster than the speed of light. I know we can talk about the speed of sound when you hear that the speed of the rocket is Mach 3 or speed of the jet is a Mach 3, Mach 2.5. That's the speed of the sound. But there's nothing that can travel at the speed of the sound or the speed of the light. One of the ways you can measure the speed of the light is the radio wave and radio frequencies. And some other things that travel at the speed of light is anything like electricity. When you turn on your computer, as soon as you press that on button, you're gonna see the computer turns on or the lights turns on because the electric current travels at the speed of light. So we're gonna put this into perspective. It's gonna be interesting though. If we measure distance from here, from the Earth to the Moon, it's only roughly about 380,000 kilometers, right? And it takes roughly about 2.5 seconds for the radio waves to be transmitted from the Earth to the Moon and back to the Earth. That's about two seconds light, 2 light seconds. Yes, I'm almost confusing between light years and light seconds. So if you remember an incident that happened in, I think it was 1969 when we launched the Neil Armstrong and Buzz Aldrin to the moon, right? So we had an incident that when we tried to communicate with them, it took us about 2.5 seconds as soon as you say, hello, are you guys hearing us out there? It took about, you're gonna hear that silent for about 2.5 seconds before you say, yeah, we're here, we're on the moon, we're having fun, there's no gravity up here. I don't know. Most of the people believe that the moon landing was a hoax. I don't believe so. There's no way that the government has inputted billions and billions of dollars and then somebody's come out and say that that's a hoax or that's a fake, that's a setup. Anyway, we're talking about light years here. So I'd say it took about 2.5 light seconds for the radio wave to travel from the Earth to the Moon and back to the Earth. So if you put in the perspective that the distance between the Earth and the Sun is about 150 million kilometers, how long will it take you to fly a rocket from here? It took, when I say the Moon was about 380,000 kilometers, it took about 3 days for a rocket that was traveling at a supersonic speed to get over there. That's 380,000 miles. Talk about here the distance of 150 million kilometers to the Sun. It will take years, probably maybe more than 20 years. If you look at the Sun, as you look at the Sun right now, right, you feel the beam of light hitting on your skin, that warmth. That beam of light left the Sun a while ago, 500 seconds ago. That's roughly about 8 minutes ago. So the speed of light from the Sun to the Earth takes about 500 seconds. That's roughly about 8 minutes. So now that one we call light minutes because it takes 8 minutes. It's the distance between the Sun to the edge of our solar system about 17 billion light years, 17 billion kilometers. Imagine the circumference of the Earth is how much? It's about 12,000 kilometers. That's really small. So now we're talking about 17 billion kilometers. That's about 16 light years because it's 17 billion kilometers. It's light hours. It's not light years. So now we move from seconds from the Moon to the Sun, minutes. Now we're moving to the hours, light hours. Now if we move a little bit out from our solar system, we get there lies a star called Proxima Centauri. Proxima Centauri lies in a galaxy called Andromeda. And the distance between the edge of our solar system to Andromeda, that's where Proxima Centauri lies, is about 40 trillion kilometers. Now we move from billion to trillion kilometers. It's about 40 trillion kilometers, I'm sorry, 40 trillion kilometers. If you divide that one in light years, we're going to get about 4.2 light years. It's gonna take you 4 light years, 4.2 light years to travel from our universe, from our solar system, center of our solar system here in our Milky Way galaxy, to the next, to the edge of our solar system, to the nearest star, that's Proxima Centauri, that resides in Andromeda galaxy. So if you talk about 4.2 light years, it's gonna take you, I don't know how many years are those, but probably about almost 1 million years to get over there, right? That's a 40 trillion kilometers from the Earth. From the center of our solar system, our galaxy, I mean not our solar system, now we're moving from our galaxy, our solar system to our galaxy. From the center of our galaxy, that's the Milky Way, to the edge of the solar system is 27 million light years, right? 27 million light years. It's going to take you 27 million light years. Probably we'll never get over there. It's going to be farther. We never ever come up with a spaceship that's going to travel that distance without being refueled to travel that distance. Of course, we will never get the food to sustain the life at that enormous distance. That's a big distance, a huge or ginormous distance we will never cover. So I've tried to put in the perspective of all this, but I'm gonna explain on my computer, because I got tonight I downloaded this planetary application that you use to design planets, but trying to put it here in a perspective that you could understand, it's kind of a little bit tedious. So I have to show it in a figure, in a number way that if you multiply and go step by step, you will understand what is light years. And again, something I forgot to talk about is so when you talk about light years, right? So when I say Proxima Centauri is about 40 trillion kilometers from here, that's about 4.2 light years from here. As you see Proxima Centauri with your telescope from here on Earth, you see, when you see any light, you see the past. So if you see the sun, you see the sun as it was 8 minutes ago. So if you see Proxima Centauri, you're gonna see Proxima Centauri as it was 4.2 light years ago. That's 4 trillion light years ago. So the best way of going back in time is by getting a telescope and seeing all those stars out there. Because when you see a star that's about 4.5 light years away, you see as it was 4.5 light years ago. So probably if we see the star like UY Scuti. UY Scuti is such a massive star, the biggest known star that we've ever discovered. It's about 5 billion times the size, the size of our sun in terms of mass. It's really huge. If UY Scuti was brought down here to our solar system, it could engulf everything from the center of from the sun all the way to the Jupiter, and that's only one star. That's how enormous it is, how big it is. So as I say, when you look at the star, you're looking at the past. When you look at the star, you're looking at it was years ago. So some of the stars that you're looking out there in space, like in deep space, not the stars that we can use visible eyes. If you take a telescope and you see a star, probably that star, you think that star as before the Europeans came and colonized Africa, before the Second World War, before the First World War. That's 200, 300 years ago. So that star that you might be looking at using the telescope has died years and years ago, maybe 1 million years ago, but we still, because we see as 2.4 light years ago. So probably died about maybe 1 trillion years later. So but still, the light didn't catch up with us until right now when you're using a telescope. But the parent star has died long, long ago. Thanks for tonight. That's gonna be too much for tonight, and I'll see you next time. Thank you.